Hello everyone, Jason here with VC Edge. In this video I'm going to be doing a little bit of work on my machine. In case you don't know, I have a Tormach 1100 MX and I've been using it for a while to make knife parts, and I've been having this slight issue with the tool changer, and let me show you some footage of that right now. As you can see, the tool changer will advance and then make a little reset noise and then retract. And it'll try to do that a couple times until it errors out completely. Now, it doesn't do this very often. Most of the time, it just, if it does have a problem, it will try once and then retry it, and it'll work just fine that time. But I think I finally understand what is happening. So I'm going to attempt to correct that problem permanently. In order to do that, we'll need to open this up so I can show you inside, and we'll take a look at what's actually happening during this tool changer cycle. It's actually not the tool changer itself that's the problem. It looks like it's part of the drawbar assembly. So let's take a look inside. So it's just gotta open up this cover. Now, when this cover is open, you normally can't do anything on the control because there's a lockout switch back here that tells the controller that that door is closed. You wouldn't want to be running the machine without that cover in place. This is the drawbar, the power drawbar. That's what opens and closes the collet inside that grabs the tool. So I want you to take a good look at this spindle when I hit the drawbar button. Hopefully you can tell on camera. It moves ever so slightly. And sometimes it moves enough so that it causes an error and it won't do the tool change. This problem has been kind of eluding me for a while. I think I finally figured it out. The drawbar piston and the bolt are not perfectly centered, and I took the bolt out and made sure that everything was flat on the cylinder side. But when you activate the drawbar, you'll see it kind of does this little dance as it's activating, and this is normal. This is what it's supposed to do. It's got a spring on one side, so it comes up early on one side and late on the other, but it comes up against this flange, and at that point it's all nice and square. But because it's going flat surface to flat surface and it does that little dance, it causes one side to contact the edge of the top of this nut. And that makes it sort of slide and cause the spindle to rotate just a little bit, enough to cause an error every once in a while. You see how it kind of hits on one side and then slides? That's what causes it to rotate. So I want to fix this permanently. There's probably a lot of different ways that you could do this. The way that I'm going to do it, I think, will reduce the possibility of any other problems being caused by the repair. So let me take this drawbar off and I'll show you what I want to do. I need to mark these hoses. I put them back in the right place after. Silver Sharpie to the rescue once again. So the drawbar comes off pretty easy. You do have to take off the hoses, although I need to turn the air pressure off first, I think. Just take these two hoses off. Take this pin out, and then this little bolt here with the spring on it. Need an Allen key for that. Okay, so 5mm, in case anyone wants to know. Okay, and then it just slides off to the side and it's out. You can see on the face of that bolt where it's been making contact, kind of all around, but mostly on more one side than the other. Then taking a look at the top of the nut that's on the drawbar, you can see there's a lot more wear on this side versus over here. So that's where it's been contacting. This isn't perfectly flat. So one thing I could do that would probably fix it is just to turn this down and make it perfectly flat, or lap the two parts together. but there's still a possibility that this, because of that little dance that the drawbar does, that it could contact off center, even if it's perfectly flat, and so is the other side. It could still cause this to turn a little bit. So what I would like to do is to have this tip, the drawbar itself, have a domed shape, so that it's only contacting in the center. So I'll have a flat surface on the top and a domed surface over here, and it'll always, no matter what it does, even if it's a little bit off center, it will always contact near or at the center line of the drawbar, and that shouldn't allow it to rotate much, if any. So that's what I'm going to do. Let's see what we've got. It does have a center drilled into the little stem here, so I might be able to use that or slightly enlarge it to fit in another piece. I'd like to keep it down to as little moving parts as possible, so just got to try to make a little dome shaped piece to fit on top of here. Just to give you an idea of what I'm going for here, I'm going to take something like this, but with a little stem on it that goes down into that hole that's already there. Maybe a slightly larger diameter than this, but to have a little ball-shaped object on the top. That way the flat bolt that comes down and presses on it will always touch the center. That little mark that's in the center of the drawbar is what's used in the manufacturing of it when they turn it. So that is a reference point that I can use for sure. This is definitely where having one of these pin gauge sets comes in handy. The hole's a little too small just to measure with micrometer and ball gauge or any other type of normal measuring system. You can use a pin gauge to find out what diameter it is by just putting these little pins in. I guess you could also do this with like the backside of a regular drill. If you don't have some of these in a pinch, you could just use that, and that'll get you really close. That one still fits, but it's a little tighter than I would like. So I'm going to say this hole is 83 thousandths diameter. So I'm going to make my post on my little ball bearing piece to be about 82. Just have to turn it on the lathe. I have some carbon steel stock here. This is 01 tool steel. I think this will work great. While it's soft, I can turn it out on the lathe, make my little dome shape and the stem on it, and then I can heat treat it to get the face of it nice and hardened so that it doesn't just flatten out after being repeatedly hit by the drawbar. I'm just going to turn this out so that I'm going to do the stem first at 82 thousandths diameter, and then I'll leave a little bit for the head, then I can flip it around. Hopefully I'll still be able to hold on to it. I might need to use some little collet or something to hold on to that tiny shank, and then I can round off the dome. First things first though, the whole thing needs to be no bigger than 0.375 so that when I take off the nut that it will clear this. I can leave this in place. So the stem doesn't have to be very deep, but this lathe isn't very capable of making deep cuts or anything, so this will take quite a while. I'll probably just come back when I get a little closer to the finish. Got this stem turned down to the size that I wanted. It's let's see what we got. 82 3/10. That'll do just fine. Alright, so it's quite a bit longer than I need it to be, so that I have something to hold on to when I flip it over. I'm just going to part this off. I'm actually not going to use the lathe to part it because this thing sucks at parting, but I'll take this out, cut a piece of this off at the bandsaw, flip it over, and then I'll dome the other side. See how small these jaws actually go down. I'm not really sure what the smallest diameter piece it can hold is. Hopefully oh, alright. Look at that. I think it will actually hold it. Although I'm going to have to put a little spacer on the back so that the face sits flat against the jaws. There we go. I'll use this. push on it while I tighten it down. Let's see if that does it. Okay, I didn't really like the way that was being held in the lathe, and I think it would just break the stem off of this thing. So I just got it chucked up into a drill, and I'll just use the belt sander to grind the dome onto the top. It'll probably take a while, but at least I have some good control over it. And I think that's about the shape that I want. It's a pretty shallow dome, so it'll be nice and strong. And now I can put this on the lathe, and I'll just use some sandpaper to polish it out. Got this sanded down to what I would say is a reasonable finish for pre-heat treat. I just need to heat up the very tip of this to a nice red color, and then dunk it in some oil. I'll hold it with these brass tipped pliers. That hopefully will keep some heat away from that little stem and keep it from warping too badly. But we'll see how it goes. Still bites. Might need to heat it up again. That should be about the right color. It cools down quick though, so I'm going to go a little bit past that. And dunk it. There we go. Perfect. So I just quickly sanded off the scale that was on the outside, and I'll throw this in the oven, and what color it turns will give us a good idea of what the hardness is. I'll try to use my hardness tester to see if I can actually get a hardness reading on it, but it's kind of weirdly shaped and might not be able to do that. So the color should give us a good idea. So the hardening's done, and got it tempered back to like a light blue color, which should be somewhere in the low 50s Rockwell C range. So this is my hardness tester. It usually has this little flat anvil. I'm going to call it an anvil. I'm not sure what the exact name is. That's the normal one that you have on it, but it does come with another one for doing round parts. So I'll install this, and that should allow me to hold this part and then measure the hardness on the side of it. Okay, looks like it's in there well enough. Let's give this a try. We're at 46 Rockwell. So it's a little lower than I expected, but it's actually about in the right range. I wanted like a low 50 is what I was trying to go for, but 46 is good. I looked up most like a grade 8 bolt, which is what I think that is on the drawbar piston, is at a Rockwell 39. So 46, it'll definitely be harder than the bolt. That'll do. I went ahead and cut that stem down. I ended up being about 140 thousandths in length, and that should fit nicely into this little spot. I will glue this in, but just with some silicone so that it can be removed later if necessary. Before that though, I want to test it out and make sure it's going to work. One thing I do need to do, as you can see here, since I added some height to this, I need to adjust this bolt length. So I'm going to take the spacer out and just cut some of it off to account for the change in distance there. This is the drawbar bolt, the drawbar piston bolt that's going to contact the face. Up here like that. I went ahead and put this on the lathe and just cleaned up the face of it. You can see what kind of wear we're getting over time. And I'm just gonna mark this up with a little bit of blue Dykem. We'll easily be able to tell where it's been contacting. Okay, so we should be able to put this back in now. And looks like my spacing's about right there. That's about the right amount of space. Let me go ahead and check it. Alright, there it is. So our gap with these two feeler gauges comes out to 65 thousandths, which is a little over what they call for in some of the instructions, but when you get the machine, it actually has a way bigger gap than that, so I'm pretty sure that's within the acceptable range. So we can put our pins back in. And hook our hoses back up. And my hands are all greasy, so that's not easy to do. Got to make sure those are in all the way. So I can turn the air back on. We can try it out. Just see how this goes. All right, looks like that's gonna work. Let's take a look at the spindle and see if it moves at all when I hit the button. If you remember how much this moved before when we would hit the drawbar button, let's see what it does now. Hardly detect anything at all, just a little tiny wiggle. I think that's a substantial improvement. Now I got to take this drawbar, sort of swing it out of the way so I can glue in the little button there. So you can just pull this pin and just sort of swing this away out to the side and it clears. So that's kind of nice. And I'll just clean this up with a little bit of acetone. Get rid of the grease. And the same thing on the bottom of the button. One thing when you're cleaning things, you always want to clean with the wet side and then wipe it down with a dry one afterwards, because a lot of chemicals, even acetone, will leave a little bit of residue. To hold this in, I'm just going to be using some of this red RTV sealant. Doesn't need to really be bonded in necessarily, it just needs to be held in place, just to keep it from backing out while it's spinning. Okay, let's push that down in there. I'll use a little Q-tip to clean up the edges. Okay, that should be good. And what I'll do to hold it down while it's drying is swing this drawbar piston back over, and I'll just put a little wedge in there and just put a piece of this material in here. Just the weight of the drawbar will be pushing down on it. That should be good enough to hold it while it's drying. As soon as that's dry, we'll run a couple tool changes and see how well it performs. Alright, so that's cured. Let's take a look at how well that spins. Just starting at 250 RPM. Looks like there is a little bit of wobble to it, but should be fine. Since it's at the center line, any out of balance won't really be much of an issue. Got the machine all warmed up, and so let's try a tool change. This is the first tool change of the day, so it has to orient the tool changer. Drawbar comes down. That worked. Okay, let's switch to another tool. Okay, I'm going to store that tool because it usually happens when the spindle is empty that it has the most trouble. everything seems to be working just fine, so I'm gonna go ahead and call it and say that this is fixed. Now that everything's good on this, I can get back to work. With that, have a quality day, and I'll see you on the next video.